having some prerequisites. So what are the prerequisites? So general fundamental mathematics is the first prerequisite. From intermediate onwards, you are studying. So the level of mathematics is also increasing step by step. And last semester also you studied the mathematical fundamentals with respect to ordinary differential equations, first order, second order, and also Laplace transform, S domain analysis also. At the same time, last semester you studied basic electrical engineering. In that, you studied the Kirchhoff's voltage law, you studied the Kirchhoff's current law, you studied the AC excitation with respect to the active and passive elements, and also you studied three-phase circuits and etc. So those are just introduction topics, and also you studied the superposition, reciprocity, Thevenin's, Norton's theorems also. Now we are going for the analyzation with respect to electrical circuits for strengthening of your subject. So while you are coming to the syllabus of electrical circuit analysis, so the course objectives will be like this. So in the first unit, you are going for the network theorems, nodal analysis, mesh analysis, dual and duality. The second unit is a transient behavior of the system with respect to time domain analysis of DC and AC excitations. And coming to the third unit, we are studying the AC steady state responses for different circuits, either it may be series connection or it may be parallel connection. And also we are studying the resonance and also polyphase circuits. While we are coming to the fourth unit, again we are studying the time response behavior of electrical circuits with respect to forced response and natural response with S domain analysis. And the last unit carries with two-port networks. So all these are the course objectives we are studying for this electrical circuit analysis course. Now, what is the outcome we are getting? A student can understand and analyze the electrical circuits with respect to network theorems. So there are different types of theorems are there for a given electrical network or a circuit. So we have to analyze and we are getting the values for the problem. And we are going for the natural response and the steady state response of a given system. So whenever the switches are on and off, automatically there must be a transient behavior. So that steady you are carrying, at the same time you are analyzing and you are plotting the waveforms with respect to RL, RC, RLC, series or parallel circuits. Then we are going for the network functions. So with respect to network functions, we are calculating the poles and zeros and what are the limitations of poles and zeros we are studying. And we are analyzing how the function will retain with respect to input excitation and outputs. So next, while you are coming to the polyphase circuits, so almost three-phase circuits are more familiar for electrical for further studies in terms of power system 1, power system 2, power system analysis. So at the same time, the analyzation with respect to study of wattmeters, at the same time we have to go for the balanced and unbalanced systems. All these studies we are carrying. Then coming to the last unit, we are going for the two-port networks. So two-port networks, it is a pair of terminals. So there are different types of parameters are there. So with respect to that parameters, you are correlating the relationship between the parameters, and also two-port networks are there, how you are connecting either series, parallel, series, parallel, series, and cascade systems. All these you are going for study in this subject, and we are analyzing the networks also. That is most important thing. And then coming to the textbooks, I am presenting in the PowerPoint 4 textbooks. So I am following these 4 textbooks, and also I have given the web link of NPTEL. So I am following these NPTEL videos also. So this is the background of this course. Now I am coming to the first unit, network theorems. Network theorems. So these network theorems are, so many theorems are there. Apart from that, in your syllabus is concerned, so it is superposition theorem, reciprocity theorem, Thevenin's theorem, Norton's theorem, compensation theorem, maximum power transfer theorem. So these theorems are there. At the same time, this unit 1 carries with nodal analysis and mesh analysis, and also the concept of duality and dual networks. Okay, so now what is the importance of network theorem study? So the study of network theorems is, so if you go for a lumped circuits, you can go for a KVL or a KCL equations. KVL or a KCL equations. So if the lumped circuit is there, you can easily calculate those responses in a particular branch, or you are calculating the voltages in a particular branches. While the complexity of the network is gradually increases, so at that time the KVL equations or KCL equations are increases. So if it is increasing, the calculation part is also increases. So most of the time consumption will be very high, while the complexity of the network is gradually increasing. That is the most disadvantage of KVL and KCL equations. So to avoid that, there are so many techniques are there in networks. So network reduction technique is there. So star to delta technique, source transformation technique, current division, voltage division. At the same time, network theorems are also there. A particular branch current or a voltage you are calculating, so you can use network theorems. And also you can go for network topology. So that is also one of the best method to go for complexity of the networks. Okay. So in this, you are going for the first one, superposition theorem. So already you studied the superposition theorem. So anyway, I am recalling the same thing. So the statement of the superposition theorem is, in any linear active bilateral networks, the overall response must be equal to the algebraic sum of the responses. So listen carefully. The overall response must be equal to the algebraic sum of the responses, and one source is acting at a time and remaining sources are made zero. So if you go for a voltage sources, so you have to put voltage is equal to 0. So that means you have to short circuit and replace with an internal impedance. If you go for a current source, I is equal to 0. So replace the current source by open circuit, and also you have to take the internal impedances. So algebraic sum of the responses when one source is acting at a time must be equal to overall response. So that is the statement of the superposition theorem. So this superposition theorem must obeys the linearity property. So now we will study the linearity property. What is the linearity property? So while we are coming to the linearity property, so linearity means it is cause and effect. It is cause and effect. So if you are giving some input, you are getting some output. So that is linear. But here the cause and effect must be proportional. The cause and effect must be proportional. So remember this. So the proportionality means the input or a excitation is changing, so automatically the output must be changes proportionally, so such type of equations or functions we can call it as a linearity. So in general mathematics also, so if you are obeying the linearity property means you have to hold two things. One is homogeneity and another one is additivity. So while you are coming to the example of a homogeneity, so homogeneity means the constant given multiplication with respect to LHS must be multiplied with RHS. Then the given equation is obeying homogeneity property. So if it is not accepting that, then you can call it as a non-homogeneity. So to understand that, I am taking one simple example. So that is y is equal to x. So that is y is equal to x. So if x is equal to 1, the y value is 4. If x is equal to 1, the y value is 4. So if x is equal to 2, the y value is 8. So that means x is doubled, y is also doubled. So initially x is equal to 1, y is equal to 4. X is equal to 2, y is equal to 8. So that means it is doubling. Then it obeys the linear homogeneity property. So this is a graph. This is a graph which obeys the homogeneity property. So while you are coming to the next equation for nonlinearity, in the nonlinearity property, so I am taking another equation. So this equation is y is equal to 4x plus 2. Y is equal to 4x plus 2. Okay. So here also I am substituting x is equal to 1. So x is equal to 1. So automatically y is equal to 2. Y is equal to 6. So that is x is equal to 1, y is equal to 4 into 1 plus 2. 4 plus 2, you are getting 6. So if you double the value of x is equal to 2, then I am getting the y value is 10. So that means if I double the x value, so you are not getting double in the y. So initially x is equal to 1, y is 6. So if you double the x value, I have to get 12. But y I am getting is 10 only. So that's why it does not obeys the homogeneity property. Does not obeys the homogeneity property. So next, coming to the additivity property. So the statement itself says that the overall response must be equal to algebraic sum of the responses when one source is acting at a time. Yes or not? So that is additivity property only. So to understand that, I am going for the simple example. So y is equal to 4x. So y is equal to 4x. So this is the equation I have taken. Now x is equal to x1, then y1 is equal to 4 into x1. And similarly, y is equal to x is equal to 2, y2 is equal to 4 times of x2. Then the overall response y is equal to y1 plus y2. So that is equal to 4x plus 4x1 plus 4x2. So now you can write the y value as a function of x1 plus x2 or 4 times of x1 plus x2. So here 4 is a common value. So x1 and x2 are there. So x is equal to 1, y is x1 is equal to 1, x2 is equal to 1. So the y value is 8 only. So if you substitute for y1 is equal to 4x1, so there you can get 4 only. Y2 is equal to 4x2, there you can get 4 only. Then the summation of y1 plus y2 is also 8. So that is the overall response. So it is additivity property. So while you are coming to the same linear equation, so that is y is equal to 4x plus 2. Y is equal to 4x plus 2. So here x is equal to x1. So y1 is equal to 4x1 plus 2. X is equal to x2. Y2 is equal to 4x2 plus 2. Now the response, overall response, y is equal to y1 plus y2. So now if you substitute, you can get 4x1 plus 2 plus 4x2 plus 2. So finally, what is the equation you are getting? 4x1 plus x2 plus 4. So that means the overall response, if you substituting for x is equal to x1, x is equal to x2, you are getting 4 into x1 plus x2 plus 4. Now the basic equation, y is equal to function of x1 plus x2. So that is equal to 4 times of x1 plus x2 plus 2. So that means it is not obeying the additivity property. Okay. So while you are going for the superposition theorem, the linearity property must obey, then only the superposition theorem will be validated. Okay. So now coming to the simple example. So here I have taken a two loop circuit. E1, E2 are the two voltage sources. So I1, I2 are the two currents, or you can call it as a responses. So now according to superposition theorem, so we have to go for individual sources acting at a time and remaining sources are made zero. So the first case I am taking, E1 is acting and E2 is made zero. So we are short circuited and replaced by internal impedance Z2. So we are calculating I1 dash and I2 dash. Then coming to the second case, E2 is acting, E1 you are made zero and replaced with the internal impedance Z1. Now you are calculating the responses I1 double dash, I2 double dash. So according to superposition theorem, so what you can say, the overall response must be equal to algebraic sum of the responses when one source is acting at a time. So I1 is equal to I1 dash plus I1 double dash, and I2 is equal to I2 dash plus I2 double dash. So this is the simple example of a superposition theorem. Now you are coming to the limitations and applications of the superposition theorem. Okay. So now what is the limitations of the superposition theorem? So the superposition theorem limitations must be taken with respect to minimum two sources. So that is, for calculation of the superposition theorem, so it must be minimum two sources and it must obey the linearity. The circuit must obey the linearity, so homogeneity as well as additivity properties. And the superposition theorem does not applicable to the networks with time varying resistors. So if the resistance is varying, so you can call it as a nonlinear system. You can call it as a nonlinear system, or you can call it as a unilateral value of resistance. So such type of electrical circuits, the superposition theorem is not applicable. And while you are coming to the applications, so there are wide applications are there, because while you are going for the distributed systems, so many resistors, inductors, capacitors are connected in series and parallel combinations. So if you are calculating any response at a particular branch, so you have to go for the superposition theorem. It is very simple. After regaining the system under disturbance also, you can calculate the further values of the parameters. So either voltage, current, or anything, power, etc., like that. And also the main disadvantage of superposition theorem is it will not applicable to power calculations. It is not applicable to power calculations. So why? Because means it does not obeys the linearity property. So that's why the superposition theorem never applicable to power calculations. Now coming to the numerical problems. So this is a example of a numerical problem. So we are going for the dependent source Ix, Iy, Vz using superposition theorem. So the given network, so this given network you are having two dependent sources, two independent sources. So this is two dependent sources. One is a voltage source with 2 volts. Another one is a current source with 11 amperes. Then dependent sources. So these two are the two dependent sources. So this one is a current controlled voltage source, and this one is a current controlled current source. Are you understanding? So the voltage 6Ix means Ix is the current flowing in 2 ohm resistor. So the current is varying with respect to this resistance. The voltage value of this 6Ix is also varies. So that's why that source you can call it as a dependent source. So similarly, this current source 2Iy, so it is dependent with respect to the current of 1 ohm resistor. If the Iy value varies, automatically the current source value is also varies. Are you understanding? So for this one, if it is a dependent sources, so you concentrate with respect to the cases on independent sources. So the first case I am taking, the 2 volts voltage source is varying and the current source I made 0. So it is open circuited. It is open circuited. I am writing the KVL equations for left loop and right loop. So for left loop, I am getting 6Ix1 is equal to 1 into Iy1. And similarly for the right loop, I can go for the right loop also. So from the above equation, you are getting 2I1 is equal to Ix1. So from the left loop and from the right loop, so you are not getting any summation points. So 6Ix1 is equal to Iy1, 2Iy1 is equal to Ix1. So that's why the values of Ix1 or Iy1 must be 0. So next, coming to the case by the application of KVL inside the loop. So we are getting minus Vz1 minus 1 into Iy1 plus minus 2 into minus of 2ix1. So finally the Vz1 value by substituting ix1 and iy1 is equal to 0. So you are getting minus 2 volts only. Now coming to the second case, the voltage source is short circuited. The voltage source is short circuited. So the current source is acting. So now we are going for the basic equations with respect to left loop, and with respect to right loop. So in this the first loop carries with 6ix2 is equal to 1 into iy2. So this is the equation you are getting. And similarly for the second loop, ix2 minus 2 iy2 is equal to 11. So this is the equation. So from this holding, so you are getting the value ix2 is 1 ampere and iy2 is minus 6 amperes. So by using this, we are calculating the ix2 and iy2. So now we are calculating the v2 value, vz2 value. So for that one, so you are getting the loop equation. So plus 2 times of ix2 plus 1 time of iy2 plus vz2 is equal to 0. So finally by substituting ix2 and iy2 with minus 1 ampere and minus 6 amperes, you are getting vz2 is 8 volts. Then according to superposition theorem, the overall response must be equal to algebraic sum of the responses when one source is acting at a time. So ix is equal to ix1 plus ix2. So finally you can get 1 ampere. Iy is equal to iy2 plus iy1. So that is equal to minus 6 amperes. And vz is equal to vz1 plus vz2. We are getting 6 volts. So this is a numerical example of superposition theorem. Now you are going for the second example. So the given circuit, we have to go for the superposition theorem for calculation of current. So that current is flowing through 3 ohm resistor. So here two independent sources are there. One is a voltage source 24 volts, another one is a current source 7 amperes, and one dependent source is there. So current controlled voltage source. So which current? 3 ohm resistor current controlled voltage source. So now for application of the superposition theorem, so the total response must be equal to algebraic sum of the responses when one source is acting at a time. So for that one, so first case I am taking as the voltage source is adding and the current source we are made 0. So means open circuited. Second case, the voltage source is short circuited and the current source is acting. So with respect to these two cases, I am writing the equations for finding the value of current I. So for first case, when voltage source is acting, so it is a closed path. I am applying the KVL. The current flowing through the circuit is I1. So I am writing the KVL equation. So 24 minus 3I1 minus 2I1 minus 3 times of I1 is equal to 0. So from this, here one equation, one unknown. So I1 is equal to 3 amperes. Now I am coming to the second case, when current source is acting and voltage source is made 0. So here I am taking the KCL. So the voltage at that node, I am taking as VA. So with respect to that, 3 currents are there. So these 3 currents I am writing. The first one is minus I2. The second one is minus 7 amperes. The third current is VA minus 3I2 divided by 2 is equal to 0. And also, what is the current flowing through 3 ohm resistor? Minus I2 is equal to VA by 3. So now substituting this value in the above equation. So if you substitute in the above equation, finally you can get I2 is equal to 7 by 4 amperes. So then, according to superposition theorem, the overall response is equal to algebraic sum of the responses when one source is acting at a time. So I is equal to I1 plus I2, that is equal to 3 minus 7 by 4. So finally you can get 1.25 amperes. So are you understand, students? Next. So in this problem, example 3. So now we are going for the determination of V value. Determination of V value. So for the given circuit shown in figure A. Shown in figure A. So here 3 independent sources are there. 30 volts voltage source is there. 5 amperes is there. 20 volts voltage source is there. So you required 3 cases for finding the voltage V using superposition theorem. So first case, I am taking 30 volts acting, remaining all other sources are made 0. Second case, 5 ampere source is acting, remaining all other sources are made 0. And third case, 20 volts voltage source is adding, and remaining all other sources are made 0. So the first case shown in figure B, so 30 volts voltage source is there. So the current source you are made 0, the voltage source you are made 0. So now at this node I am taking as V1. V1 is the node voltage. So in this equations you are getting 3 currents. You are getting 3 currents. So the first current is 30 minus V1 by 6. The second current is V1 by 3. The third current is V1 minus V1 by 3 overall by 2 is equal to 0. So this is the value you are getting. So here V1 is only one unknown value. So finally the voltage V1 is equal to 6 volts. Now coming to the current source, 5 amps current source is acting. So 30 volts voltage source is short circuited, 20 volts voltage source is short circuited. Now I am taking this node voltage is V2. Node voltage is V2. So here also 4 branches are connected in parallel. So 4 currents you can get. The first one is V2 by 6. Second one is minus 5. Third one is V2 by 3. And final one is V2 minus V2 by 3 divided by 2. So this is the value you are getting. So from that here also only V2 is the unknown value. So V2 is equal to minus 6. Then coming to the third case, so current source is open circuited, 30 volts voltage source is short circuited, only 20 volts voltage source is acting. So here the 6 ohms and the 3 ohms, they are directly parallel. They are directly parallel. So R equivalent is equal to R1 R2 divided by R1 plus R2. So 6 into 3 divided by 6 plus 3, 18 by 9. So finally you can get 2 volts. So this is the 2 ohms is connected in series with a voltage source, in series with a resistor, in series with a dependent source. So now applying the KVL. So if you apply the KVL, so finally you can get minus 2 times of I, minus 20, minus 2 times of I, minus V3 by 3 is equal to 0. So this you are writing directly with respect to the current as minus 2I. So finally you can get I is equal to 6 amperes. So now what is the voltage drop across this 2 ohm resistor? So that is V3 is equal to 2 into I. So 2 into I is 6, finally you can get 12 volts. So therefore according to superposition theorem, the net voltage is equal to algebraic sum of the voltages when one source is acting at a time. So V is equal to V1 plus V2 plus V3. So plus 6 minus 6 plus 12. So finally you can get 6 minus 6 plus 12. So 12 volts is the final value. Next. So now coming to the fourth numerical example. So this is a circuit given with respect to two independent sources. One is a voltage source, another one is a current source. 2 amperes current source is also there. So one dependent source is there. So 4 into I. So here you have to go for the determination of I value. So I is the current flowing through 3 ohm resistor. I is the current flowing through 3 ohm resistor. So here also you can get 3 cases. So 2 current sources and 1 voltage source is there. So first case I am going for 10 volts is acting. So 2 amperes current source is made 0. 8 amperes current source is made 0. So this is the equivalent circuit you are getting. So apply the KVL for this circuit. So if you apply the KVL for this circuit, so minus 4 times of I dash plus 3 times of I dash minus 10 plus 2 times of I dash is equal to 0. So finally you can get, after simplification, I dash is equal to 10 amperes. Then second case, 2 amperes current source is acting. So voltage source is made 0, short circuited. 8 amperes current source is open circuited. So the equivalent will be shown in this figure. So here 4 branches are connected in parallel. So for this parallel combination, we are going for the calculation of the current. So 3 ohms and 2 ohms are connected in parallel. 2 current sources are there. One is a dependent, another one is a independent current sources. So net current must be, you have to write 2 plus 4I double dash. 4I double dash. So now what your consideration, 3 ohm resistor current you have to take. So that is I double dash value you have to calculate. So by using current division method, so we are going for the calculation of current. So I double dash is equal to 2 by 2 plus 3 into net current 2 plus 4 double dash. So finally you can get I double dash is equal to 2.4 amperes. So next, coming to the third case. So third case is 8 amperes current source is acting. Remaining sources are made 0. So I triple dash we are calculating. So for this one, so I am going for the application of the Kirchhoff's voltage law for this loop. So we are getting minus 4 times of I triple dash plus 3 into that current value. So what is that current value? I minus 8 amperes. I minus 8 amperes plus 2 times of I is equal to 0. And what is I triple dash value? I minus 8 only. Or I is equal to I triple dash plus 8. So if you substitute this in the above equation, so finally you can get I triple dash is equal to minus 16 amperes. So according to superposition theorem, the net current must be equal to algebraic sum of the net currents when one source is acting at a time. So finally 10 minus 2.5 minus 16, so you are getting minus 3.6 6 amperes. So this is the example for superposition theorem.